All right, so let's go over 7-2, the start of our next chapter here. So we're going to kind of go a different direction. So definitely have done a lot of matrices. Now we're going to look at sets and groups and probability. Okay, so sets. If I'm looking at different sets of things, this first symbol right here is representing a union. And what is a union? If I put together, I union together two classes, right? Then I'm putting everything from one class and everything from the other class together. So this is trying to say all elements from group A or group B. So your union, you're kind of collecting them all, okay? So let me write for you. Let's write what these symbols mean, just because you're going to have to get used to this. So if I say I don't know how to write this little funky E, A ear like this, I am saying little a is an element of big A. So just a little side note for that symbol. We typically use a capital letter for our sets. So the sets are like capital A, capital B. And this little line right here means like X such that is how I learned it. So it's like X such that they're in this set or whatever it is. So it's usually like the X is the element, like maybe the number 1 is in the set of integers. And so you would have 1 and then a line and integers or something like that. So that's kind of what that line means. If I have this intersection right here, this is what's in both. So think about the union picks up everything, right? But the intersection doesn't. It's like what's in common. So what's in common right now for the class that this business applications and business calc? Well, this semester that I'm making this video, there are 3 people in both. So they are my intersection. They are in both courses. Okay, so, and that's what this is saying right here is all values, X, all X's, right, are in an element of A and an element of B. So imagine that the intersection is less things than a union. A union is like, all right, we're all going to become one. Okay, what's a complement? A complement is what's not in something. So when I see this symbol, I think the word not. If you've done calculus, I also think derivative, but they're not related. So those of you in both classes might get a little confused. Sorry. So it means not in this setting. I don't know why they use the same symbol. But we're not in function notation, so we don't have the F parenthesis. So that might help, or we don't have a Y. It's usually on a set like A, B. So if I'm not in A, you would be all elements, data, whatever. X is just our, what we're putting in, our elements, or our numbers or whatever they are elements of U where they're not in A. So that's kind of weird writing, but it's like anything in the universe, anything in this setting that's not in A. So I could be who is not in business calc that is in this class right now. Our universe is this class. Then it would be everyone who's not. Oh, all right, you can make fun of me, but I worked out and my nose keeps running from being too hard of cardio. Okay, so let's look at some examples here. I don't know that I want to do every single one, but definitely we need to look at some. So let's look at this first example here, and it has all these numbers and it says intersect with this. It is basically saying what are the intersection numbers between the two? And the intersection numbers would be a set of numbers. So I'm going to use a set bracket. And they both have the number 1, no, but they both have a 2. They both have a 3, so a 2, a 3. They both have a 5, 5, no 8, no 7, oh, and a 13. And that's it. So the intersection is 2, 3, 5, 13. So you use those little bracket symbols, and you'll have to use those in my math lab as well. Sometimes they already have them on there, so you'll just have to look at the problem. But okay, problem 2 is a union. So I'm unioning this set and this set here. Here's the only trick with this: don't repeat a value. So if there is, why is there dots? That's totally a misprint. Funny enough, my paper that I have right here has commas, and this one has dots. So I don't know what version is going to be on your thing, but these are commas. Funny. I don't know. Make them commas if they aren't. So which numbers repeat? They both have a 6 and they both have a 9. So when I write those down, I write them down once, but I'm getting every value. So I'm going to go 3, 4 from over here, 3, 4, 5 from right here. Only list the 6 once, but that takes care of both. No 7, but I got an 8. And again, the 9. So there's the 9s and a 12 and a 14. I just cross them out to make sure I got them all. So there is a union of 2 sets. All right. I'm going to skip 3 and 4. You can try them on your own. 3, you should get A and E. And 4, you should list them all, but don't repeat anything. Okay, 5. What is the intersection between the numbers given here and prime numbers less than 10? So we have to think of what are the prime numbers less than 10. So a prime number less than 10 could start with 2. 1 isn't considered prime because it's not divisible by 1 in itself. It doesn't have another number. So, okay. And then we have 2, 3 is prime, 4 is not, 5 is prime, 6 is not, 7 is prime, 8 is not, 9 is not, and 10 are not. So 2, 3, 5, 7 are the numbers that are prime less than 10. So then we take those ones there and we say, okay, which ones intersect with these ones? Well, they have a 2, 3, 5, 7. So all of them. So I do my little symbol, 2, 3, 5, 7. Okay, problem 6. Well, this is still 2, 3, 5, 6, but this time it's a union. So we're going to list everything. So we start with the 2. We have a 2. And remember, this is 2, 3, 5, 7. I think I said 6. You probably heard me say it wrong if I did. I swear I said 2, 3, 5, 6 and not 7. But anyway, and then we have the 4. And oh, I forgot the 3. It's okay if they're not in order. 5. It'll take them out of order too. It's just me. 6, 7, 8, 10, 12, 14, 16. Did I list every number in both sets and only list them once? I think so. Okay. 7. For our universe, everything in our world is listed right here. Okay. And it says A is this. What's not an A? Okay, well, let's look. What is not an A? Well, I and O are in A. So what's not in A is the set of A, E, U. And we could label it like this too. Okay, the not A is this. Okay, for 8, it says not A again. So not in A would be Ooh, it can't be the 2, the 4, the 6, the 8, and the 10. What's left would be the 1, the 3, the 5, the 7, and the 9. It looks like odds are left, evens are in A. Okay. I don't know. Oh, one thing I want you to put to the top too is this is an empty set. I'm thinking of it. That's our symbol for like, there is nothing in that set, because I could ask kind of a tricky question that doesn't have anything in its set. I was trying to think, we got the, I don't know if we need to do, let's do 11. So 11 says, if P is the set of 1, list all of the subsets of P. So a subset, man, that's hard to do with just the number 1. Let's look at 12. That's kind of silly. It's only one number. So a subset is a group of the set of the numbers you see. So a subset could be just the number 1. I don't know why I put a comma. It could just be the set of the number 2. Those are 2 subsets, because a subset is like part of that big set, right? Everything in the subset is from the main set, but our main set only has the numbers 1 and 2, so kind of silly, but there we go. Another one could be the full thing, which I know seems strange, but think of it this way, like, oh, I'm going to take a subset of this class and it happens to be everybody because the class was small. It's still a subset, but I know it doesn't seem like that's what it should be. The other one is an empty set, which you can go like this or this. Either one. You could do a blank set of nothing or the symbol. I really got to stop working out. It's really bad for you. Okay, number 13. List all the subsets of this one. Okay, this one has 3 numbers, so I'm just going to say them. I could have 1, 2, 3. I could have the empty set. Got those 2. I could have a set of just 1. I could have a set of just 2. A set of just 3. I could have a set of 1 and 2. I could have a set of 2 and 3. I could have a set of 1 and 3. Okay, too lazy to list them all out, but that's what it could be on 13. All right, let's look at a Venn diagram, and still using all the same symbols. But let's say this whole thing here, what is this symbol? Oh, I don't know what that does. Okay, so I was thinking that little hand might do something different. I'll just use my dot. I like to point to things with my finger and you can't see it. So that's, yeah, I got to remember the dot. So look at this whole Venn diagram. This represents the full universe. That's why they label it a U. And they're saying you have set A and set B. And set A has 80 numbers of just in A. So does it say what A and B are? No. Maybe set A are, I can't even think of an example. Well, I'll think of something in a minute. And then B, or maybe not. B is this set over here. And then there are 20 in set A and B. And this number over here represents all of the ones that are outside of A and B. Okay, that's kind of how that Venn diagram is set up. We're going to actually draw one as well. So if we look at this, what is question A asking? It's saying how many are in the universe? That's, I like to think of it as a universe. I don't really know what it stands for. I totally made that up. Or somebody said it once. I was like, that's a good way to think of it. So how many are totally in that universe, in that whole square? Well, 150 are outside of the circles. Then you have 80, 20, and 50. So you have to add up all of those. So we would have 80 plus 20 plus 50 plus the 150. So if I add up those, it's 300, right? 2, 1, yeah, 300. So there are 300 total in the universe. Trick question. B is like, how many are not in the universe? Well, actually, sometimes they put a number out here and that would represent not in any of the sets. So maybe set A is in a math class, set B is in a history class, and these are like people who aren't in either of those classes would be outside. But we don't have a number over here, so we would just say 0. How many are in that? None. There's no numbers in there. Okay, how many numbers are in the intersection of A and B? Intersection. It's going to be where it crosses over together. So there's 20. Okay, for D, what's the union of all of them of A and B? It's the 20 in the middle, the 80 and the 50. So 150. Okay, how many numbers are for E? How many numbers are not in the intersection, or excuse me, the union of A and B? That would be the 150 that's out by itself, right? So it's the 150 out by itself. How many are in A but not in B? Okay, a little bit trickier for F. How many are in A but they don't overlap with B at all? 80, right? These are in B too, can't include those, so just the 80. Okay, how many are not in A but they intersect, not A intersect B? So how many are not in A but they intersect with B? Would be the 50. Not in A, yeah, just the 50. Okay, last one. How many are not in A and not in B? Well, 150, the outside one, right? Not in A, not in B. Okay, I think it has an example of making, oh no, they just give you 2 different ones. Okay, hang on. They give you, for, I know I wrote one down somewhere. I want you to be able to actually come up with, nope, I didn't write one down somewhere. Just kidding. Okay, let's make up our own. So let's say in math, there are, let's just do 220 students in math classes right now. And in English, there are, I don't know, 110. We'll say they like math more. That's, we all know that's probably not true. And let's do history, just for fun. And we'll say there are 50 people in history. Okay. And then we're going to say there are 4 people in all 3. Okay. We're going to say there are 10 people in English and math. Okay. We're going to say there are, I want the numbers to be easy to subtract, 15 people in English and history. Last subset would be math and history, and we'll say there are 5 in math and history. And we'll say there are a total of, I got to make sure it's big, we'll just say 1,000. 1,000 total at the school. Okay, I wrote that really bad. Okay, so how would I make my own? Well, this one has 3. I would make my square that represents, or rectangle, whatever, it represents that full universe. And I have 3 sets, so I don't want just 2 circles. I want 3. So I'm going to have 1, 2, 3. And this would be math, English, and history. Okay. And what we do is we start with the middle. How many people were in all 3 type of classes? There were 4. That's what we set up. There are 4 people in all 3. Okay. Then we look at between math and history. Between math and history, we said there are 5 people between these two, but we already have 4 in between. So how many are left for this section right here? So it would be 1. So you have to be careful of the way they word it. Now they could word it like that 5 would go where the 1 is, but typically you don't. It's not. Okay, so English and history. English and history had 15, but there's already 4 there. So now we have 11, so that adds to 15. And then math and English, we said 10, and there's already 4, so there's 6 left here. Okay, then for math, we say that this whole circle has 220. So we have to take 6 plus 4 is 10, plus 1 more is 11. So we have to take 220 and minus the 11 to get 209 left here. It's like the total math, people, all the math have to add to that. So it is way trickier to make a Venn diagram than to read a Venn diagram. Okay, English, we can have 110. So 6 and 4 is 10. So 21 minus 110 is 89 total left over here. 12, 13, 14, 15, 16, right? 4, 5, yep. 16 in history. So 50 minus 16 leaves 34. Okay, then we know there's 1,000 total, so we have to come up with the number that's in the box. It's still at the school, right? This represents people at the whole school. So I'm going to take all of these numbers, all of those, and subtract them from 1,000. Okay, so 209 plus 1 plus 4 plus 6 plus 89 plus 146, 11 plus 34. I think I got them all. Oops. I got 354. 209, 84, 34, 11, 4, 6. I think I got it right. So 354 total. And so minus that from 1,000. And I got 646 that were left, that were not in a math, English, or history class. Okay, so I totally made that up, but then you could ask questions of, like, if you wanted to draw a Venn diagram, then you could ask like, okay, how many people just took a math class? 209. How many people did history and English? Well, you add those together, 15 for the 4 and the 11. Yeah, so you could ask questions about it, but that's how you draw a Venn diagram. All right, that's all I got for this lesson. Should seem easy after all our hard matrices, I'm hoping.